Our next speaker is Dr. Russ Schumacher. Dr. Schumacher is a professor in the Department of Atmospheric Science at Colorado State University and serves as the Colorado State Climatologist and director of the Colorado Climate Center. He received his BS in Meteorology and Humanities from Valparaiso University and an MS and PhD degrees in Atmospheric Science from Colorado State University. Working closely with graduate students, Russ's research career has centered on advancing the understanding and prediction of high-impact weather systems. A particular focus has been on storms that produce extreme precipitation, using a combination of observations and models. His research group developed a forecasting system that uses machine learning to generate probabilistic, I had to say that a few times, I probably butchered that, but predictions of excessive rainfall and severe weather, known as Colorado State University Learning Machine Probabilities, which is now used operationally at NOAA's national centers and throughout the weather enterprise. As state climatologist, Russ and the Colorado Climate Center team provide actionable weather and climate information to a diverse group of stakeholders that includes state government agencies, agricultural producers, water managers, and the general public. He oversees the highly successful community collaborative rain, hail, and snow network, as well as the Colorado Agricultural Meteorological Network. So, thank you.
Well, thanks, Paul. Thanks for the invitation. Always great to be here in the San Luis Valley. Everywhere in Colorado has interesting weather, but I think you maybe have the most interesting weather in the state here. And just driving down last night, seeing the incredible clouds over the Sangre de Cristos and thinking that you all get to see that every day is great. So yeah, I'm gonna give a bit of update, a little background, I guess, on the weather and climate of the valley here and where things stand right now, which you've already heard some of the bad news there, which I will reiterate, but I think it's that's why we're all here this morning, right? So first, just a little bit of background introduction to our office, the Colorado Climate Center. So back before the 1970s, there was a federal program of state climatologists, which was done away with in 1973, and so then each state kind of got to decide what to do at that point. And what many states did was they set up a state climate office at the land-grant university or the ag school in their state, which is what Colorado did. So our office was established in late 1973, I think, in the Department of Atmospheric Science at CSU, and we've been there ever since. And so we talk about our mission as three things. So climate monitoring, which I'll show you quite a bit of here today, keeping track of what's going on around the state. Some applied climate research related to things like drought and water and snow and floods and so forth. And then climate services. So we're here, our office is here as a resource. If there's data you're looking for that you can't find, or want somebody to come give a talk at a meeting or whatever, that's the sort of thing we do. So don't hesitate to reach out and get in touch. Okay, so let's dive in, and I always like to start with this just to kind of set the stage of what we mean when we're looking at the climate of Colorado. And this is not a map of weather and climate, but it's a big driver of our weather and climate, which is the topography of our state, with the color scale that I built based on the colors in the state flag that I think looks kind of slick. So you can see the reds are the lower elevations, the blues and the whites are the mountains, and it's really diverse, right? I mean, we all know this. You can look outside here in the valley and see so many different topographic features. So across the state we have everything from the eastern plains, the river valleys, the Arkansas, the South Platte, the valleys you see on the western slope. The San Luis Valley, sits in southern Colorado there, surrounded by mountains. So highly varied, and that really drives the variations that we have in our weather and climate. So this is the map of topography. This is a map of average annual precipitation, right? And going back and forth, and you see they line up, quite closely in most areas. And again, huge variations over small distances, and nowhere is that more apparent than here in the San Luis Valley that gets maybe 7 or 8 inches of precipitation per year on average, and you go an hour drive to the west and you're up over 50 inches of precipitation on average in the San Juans, which comes in the form of hundreds of inches of snow, at least in most years, maybe not this year so much. But again, you see the variations everywhere. So in some of what I'll show it for brevity, we take the average over the whole state, but that's always misleading because really we have many different climates in Colorado, not just one that's defined by an average. And I like to show this map to drive that point home as well, which is at first glance maybe like a splattering paint on a abstract art or something like that. But what the color shows is which month is on average the wettest month for that location. And so, like, if you look, the northern Front Range, that dark green color is May, is the wettest month. Like in Fort Collins, where I live, southeast Colorado is mostly July. Here in the San Luis Valley, mix of July and August. But then you go to the mountains, of course, and then the winter is the wettest time of year. That's the like dark purples and blues. So the mountains get most of their precipitation in the winter. The low elevations on the western slope are either spring or fall, like April or September, October. So every color is represented in Colorado somewhere on the map. And we're the only state that has that. So there's not a quiet season when it comes to weather in Colorado. You just have to change where you look, and then that's the active season in that location. So that it makes our jobs very interesting, but also challenging. And then this relates to water, right? This is the big issue. This is why we're all here this morning is for water. This is river flows is actually a little bit of an older graphic. Most of these numbers would be a little bit smaller in a more recent average, but it illustrates, right, that the much larger river flows out of the state are to the west, eventually ending up in the Colorado River. Much smaller flows to the east or in the valley here to the south in the Rio Grande. But most of the population of Colorado lives east of the Continental Divide, right? It's actually about a 90-10 split now, like 90% east of the divide and 10% west, but a lot more water on the west side, which brings many of the challenges that we'll hear about through the day. Okay, so that's that kind of background of the climate of Colorado and what we are concerned about. Let's take a look back at last water year. Maybe that's a little bit more happier news before we get to the current conditions. So this goes back to water year 2024, seems a while back now, so October 2023 through September of 24. The left map is the ranking for temperature across the state. So the red colors are warmer than average years or ranked among the warmest years on record, and then the right map is for precipitation. So the temperature map is mostly red. It was a very warm water year for the state, the 6th warmest water year going back to the late 1800s statewide. Most places were in the top 10 warmest water years. But it was quite an active water year for the San Luis Valley here. So at Alamosa, for example, over 2 inches above average, which when the average is 7.5, that's a pretty big bump up there. And so some places a little bit farther south in the valley had their wettest water year on record. From May through, this is just kind of a remarkable stat to me, from May through October, Alamosa was more than 3 inches wetter than both Denver and Fort Collins, which had never happened before. That was, it was wetter than average here and much drier than average up to the north. But still quite a some remarkable stats there. But I think also, right, I think you all are familiar with the fact that the water here in the valley mostly doesn't come from the rain that falls in the valley. It comes from the snow that falls in the mountains surrounding. So 10 inches of rain, way above average, but still not that much water in the grand scheme of things. And then November, things were looking great, right? We had this huge snowstorm in early November. Here in the valley, but especially in southeastern Colorado, these are just incredible amounts of liquid. This is the liquid water that's shown here. A lot of places with 3-4 inches of liquid from this one storm, and same up in the Sangre de Cristos. So huge storm, and got this new water year off to a very wet start. And I think if we were looking at things in November, probably had some good reason for optimism, and then there wasn't much. There hasn't been much since then. So if we look at the winter so far, or this was winter, December, January, February, temperature ranking on the left over the historical period, and precipitation on the right, very warm and dry in southern and western Colorado. So extremely warm here, especially in the San Luis Valley and along the western slope. Very dry in western Colorado, so some like around Montrose, driest winter that they've ever had, and all those, the second to darkest brown color is all in the top 10 dry winters in those areas. So here in Alamosa, really kind of eye-popping statistics in terms of the warmth here, especially in February, which you all, it's not that long ago. I'm sure it comes to mind. So warmest February on record for Alamosa, third warmest climatological winter. 8 days of 60 degrees or higher in February, which the previous most in a winter was 5. Got to 67 degrees on February 3rd, which was the warmest winter day on record for, if we count winter as December, January, February, as we typically do in our work. So very warm. That goes along with not having much snow on the ground, and those are actually closely tied here in the valley, right? If you have a bunch of snow cover, keeps the temperatures down as well, or if you don't have snow cover, then it's more likely to warm up. So we already saw this map, or a version of this map, in the previous presentation. Snowpack percent of average as of a couple days ago, and the numbers do not look good across the southern basins here in Colorado. The northern part of the state, mountain ranges, not doing too bad, but quite low here in the southern part of the state. And if we zoom in on southern Colorado and the kind of sub-basins in here, we can see some of that variation that we saw in the table in the previous talk as well. So again, even on the north end of southern Colorado, like the headwaters of the Gunnison River, not so bad, closer to average, but further south and east, pretty concerning numbers. And it's especially actually the mountains, like the Sangre de Cristos, the areas that flow east into the Purgatory or into the Arkansas, that are really, really low, but not good numbers anywhere here in the Rio Grande Basin. And we saw this as well, so we'll just kind of emphasize it again, right? That the news is not good in terms of the snowpack and the water supply here in the basin. So this is for the upper Rio Grande Basin as on a whole, same plot that we just saw. But I'll point out just a couple of other things here. They highlighted last year as a good point of comparison, being a pretty decent water year or snowpack year, close to average. Again, this year is in the black, and I guess took the pessimistic view and pointed out 2018 as the like pink line near the bottom there. So we're a little bit above that for the basin as a whole, but not by much. The average peak is in 5 days from now. We're clearly not going to get to the average peak in the next 5 days because the snow has been melting over the last week as opposed to building up, and so about 7 inches short of the median peak, and that may, if we use the numbers by tomorrow, they might look even worse. So again, not really good news as far as the snowpack that feeds into the Rio Grande. Again, not as bad as 2018, definitely not as bad as 2002, at least at this point, but in the conversation of 2018 as kind of an analog year, as we heard. And some of this is also just kind of a little bit mind-boggling from where we were in November. So this is one particular SNOTEL station. This is at Hayden Pass up to the north. If you look there in November, it was about 2 inches higher than it had ever been at that point in November. So that that's pretty good news that you'd be looking at as of November, and then basically, very little accumulation of snow since then, and then you see the drop off from the warmth of the last week. So the atmosphere got us. Got hopes up in the fall, and then has dashed them since then. All right, so let's zoom out and kind of see where this all fits in the big picture of a changing climate. So this is the updated state climate change in Colorado report. It was published about a year ago that our office led in collaboration with the Colorado Water Conservation Board. I'm just going to show a couple of things from this here today. But if you're interested in more details, it's climatechange.colostate.edu for all the graphics and more explanations and so forth. And yeah, thanks. Becky Bollinger was the lead author, and Peter Goebel and Jeff Lucas were the other lead authors on this report. So Chapter 2 of the report deals with the key climate variables of temperature and precipitation, which we have the most records on and are have the most confidence in what's going on. So the way we've broken it down is basically what's happened recently, what is the projected future change, and what is the confidence in those future changes. So if we look at temperature, the recent trend has been warmer. Projected future change is warmer with very high confidence, and I'll show some of that here in a second. Precipitation is a different story. The recent trend has certainly been lower, but it's unclear what that will do in the future. So there's low confidence about the future changes. But just the effects of rising temperature have important implications for water, as we'll get to here in a second. So here is temperature going back to the late 1800s in the Rio Grande Basin. So if you see red years, those are years that were warmer than the late 20th century average. If you see blue, those are years that were cooler than the late 20th century average. You see since the 1980s, 90s, a lot more red bars than blue bars in there, which reflects that warming trend that is across Colorado and across the planet. So here in the Rio Grande Basin, using NOAA's data set, it's 7 of the 9 warmest years going back to the late 1800s have been since 2012. So 7 of the 9 warmest years in the last 13. 2024 was the 9th warmest year for the Rio Grande Basin, but if you compared last year to all the years before 2000, it would be, like the 3rd warmest or something like that. So pretty distinct warming trend here, as with most other places. Here's precipitation now, which is a much more complicated story. So here again, green years are water years that are wetter than average, brown are drier than average. And rather than any real long-term trend here, it's really just dominated by variability year to year, decade to decade. You can pick out particular dry periods. We have had a lot of very dry years since 2000 or so, but they rival some of the dry years back in like the Dust Bowl or the 1950s in terms of precipitation. So that's kind of what we're looking at there. So what does this mean? What are the implications for water? That's what we're here today to discuss. So a few different variables here in terms of, again, recent trend, projected future change, and the confidence in that change. There have been trends toward lower snowpack with kind of medium confidence, but a more robust trend towards earlier runoff. And I'll show that in a minute. And I think the San Luis Valley or the Rio Grande we've been seeing that probably the most of anywhere in the state in terms of the shift towards earlier runoff. Again, changes in total stream flow or the peak stream flow have trended lower, but not with as much confidence as, say, the timing. But the robust trends come in evaporative demand, which I'll touch on next, and then that going up means soil moisture goes down in the summer. So I think everyone's familiar with this idea, right, that, and especially in the high desert here, that When it's warmer or it's windier or if the air's less humid, that air is thirstier for water. So it's going to pull more water out of the soils, the crops, the forests, the reservoirs, whatever. So this is evaporative demand, the air's thirst for water. And when it's warmer, that goes up. So this is a graph very similar to the one I showed a minute ago, again, just for the Rio Grande drainage, kind of long-term wet periods and dry periods. This is for precipitation only, and kind of gives you an idea of some of those historical, like think of this as the natural fluctuations in precipitation, going from, wet periods to dry periods. So you can see here in this part of the state, the big drought around the turn of the 20th century. The Dust Bowl shows up a little bit here, but it's really the 1950s where the drought was particularly acute here in the valley. And then you see the more recent, the wet periods in the 80s and 90s, and then the recent drought periods since like 2002, 2018, 2020, 2012 in there. With a little bit of a bump up now in the last couple of years with some wetter than average conditions. But what I'm going to show now is kind of adding in the effect of that increased thirst that comes from higher temperature. And so the whole graph will change, but especially if you keep your eye on the right-hand side of the graph in the last 20 years or so, it changes quite a lot. So here's precipitation only. Here's the effects of precipitation plus temperature change, and you see, on the right-hand side, it goes from fluctuations, dry, wet, to a lot of dry, right? And this is the crux of the issue of how climate change is affecting drought, in that it's becoming more of this issue of hot drought, that it's of course partly driven by precipitation deficits, but also then exacerbated by rising temperatures. And so what happens is you take the years where you have more than the usual precipitation, and then that water doesn't go as far, and then when you have the years where precipitation is low, it's even worse. The impacts are even worse because of that increased demand for water from the atmosphere, and then that also means more demand for water from water users because there's not as much around. So it makes the wet years not as good, and it makes the dry years worse as temperature goes up. And then the other implication of this is on the timing of stream flow. And again, so this graph is for the Colorado River, but it might, if you looked at it for the Rio Grande, it might actually be even more stark. What it shows, so the black line here is like the late 20th century average stream flow on the Colorado River near Dotsero, but you can think of this for most river systems in the western U.S. And then all the blue lines here are different climate model projections of the future. And so you can see some of them have the peak stream flow actually going up, some more of them have it going down, but every single one of them, it shifts to the left, it shifts earlier. So what does this mean? It means that the stream flow probably goes up a little bit actually in that April time period, as was already mentioned, right? Like some of the water is already flowing now at the end of March, the beginning of April, which maybe you wouldn't usually have because it would still be in the snow. But then it means a big decline in the late summer, where you go back to base flow much earlier than had been the case in the past. And of course, this is when you need the water, right, is in July and August when it's hot. You don't need the irrigation water so much in April when it's still kind of cool. So this timing shift is a big challenge, and we've seen quite a few years like this here on the Rio Grande, for example, in recent years, where maybe the peak stream flow is not all that bad, but it was a few weeks earlier than it would have been on average historically. All right, so let's take a look now, not looking off into future climate change, but in the more near term. What do we have coming over the next week? So there's a storm going on right now up in northern Colorado. We're finally getting some rain up in Fort Collins. We've been very dry up there as well. This current pattern, not this storm this weekend, it's going to be wind here in southern Colorado, not so much precipitation. And so that's continued below average over the next week here in southern Colorado. But there's a little bit of hope in the outlook going out say, late next week into next weekend, there's some potential for a pretty big storm in that time period somewhere in the western U.S. It's hard to narrow it down much more than that at this point. So it's getting our hopes up, but it may, we know that the hopes have been dashed many times this winter already, so we'll see. But keep an eye on that. I think if nothing else, the pattern is going to turn cooler over the next couple of weeks. So at least we shouldn't after like this weekend, we shouldn't at least be accelerating that melt so much, and maybe we'll get build some more snow back up into the mountains. But then looking out into this is for the season, the April, May, June time period, seasonal outlook. So think of this as like the confidence that it will be warmer or cooler than average. Well, here all you see is warmer than average on the map. Higher confidence the farther south you go in the United States. So that includes, I've put the dot on Alamosa there. Increased odds of a warmer than average April, May, June time period, and increased odds of drier than average April, May, June. And so this is not the kind of outlook you want to see when the snowpack is already low and we're already very concerned about the expanding drought over the coming months. Always take these with a grain of salt. What I usually tell people is they're right more often than they're wrong, but they're also wrong a lot. So, seasonal forecasting is really difficult, but that's also a pretty high confidence outlook for warm and dry across southern Colorado going forward. All right, so just to wrap up, a little bit of advertising for some projects that we run out of our office. So one is COAGMET, Colorado Agricultural Meteorological Network, which we also call Colorado's Mesonet. These are automated weather stations, mostly in the agricultural production parts of the state. So you can see the station locations there. We've got 5 stations here in the valley. 2 around center, and then down in the southern part of the valley as well. So these provide data every 5 minutes, measurements of temperature and winds and humidity and liquid precipitation and solar radiation, all the things you need to calculate reference evapotranspiration. So that thirst for water, which can help to inform irrigation planning, et cetera, et cetera. We also measure soil temperature, and we're starting to add in soil moisture measurements at more of the stations. And this data is all freely available. And we recently upgraded the website, so it's coagmet.colostate.edu. There were the high temperatures from the other day, very, very warm for late March. But you can get reference ET, you can get maps of rainfall in the summer, temperature, wind, et cetera. So hopefully you might find that useful. And then lastly, I have to wrap up with the advertisement for COCORAS, the Community Collaborative Rain, Hail, and Snow Network. Do we have any COCORAS observers here? 1, 2, there's a couple. All right, good. So let's increase that number a little bit today. Maybe some of you will be interested in joining. I've got some brochures if you want to grab one, or there's one I put some on the CSU extension table out there. So all you need to do is get a rain gauge. That's the one requirement, is this particular rain gauge, so it's consistent across the network, but it's a simple plastic rain gauge you put in your backyard or your field or wherever is convenient, and you measure it. And I guess here in the valley, a lot of days you'd be measuring 0, and so that's really easy. You just go and it takes like 2 seconds to put in a 0. So the zeros are really important, but it's also important to know when it does rain or snow. So the website is cocoras.org. Here's a map from southern Colorado from the big snowstorm in November. So I don't know, are any of you the ones up on the 40 inches plus there from that storm? So those are great measurements to get those 40, and over a foot here in the valley. but it would be awesome to get more dots on the map here in southern Colorado. So I will wrap up there. There's our office website, my email if you want to get in touch. If you want to geek out on weather and climate stuff, we do monthly updates for the state that you can subscribe to. And if you really want to geek out, then we have a blog where we take kind of deep dives into some of these topics that you can separately subscribe to there. So thanks so much for having me. Happy to take a question or two if there's time.
Yeah, we do have a couple minutes for questions before we take a break. So if somebody has one, I can run the mic over to you so folks online can hear.
There's one over there.
It's just a small question. What's the difference between a climatologist and a meteorologist?
Yeah, great question. So the question, if you didn't hear, was what's the difference between a meteorologist and climatologist? And I guess I personally sort of make that line really fuzzy because my training, my research is very much on the weather side, the meteorology side. But then, right, climate is the statistics of weather, and so you know they're linked, right? And so like what I do is I guess I try to bridge that gap a little bit to because there's people who study climate from the perspective of like the weather is just noise. I don't really care about it. I just want the statistics. And as people, that's not how we experience things, right? It's like the weather is what we experience every day, and so yeah. So I'm a little bit of each, I guess. As I'm by education a meteorologist, but have kind of tried to weasel my way into the climatologist world as well. Because it's not a sharp cutoff, right? Like weather and climate it's a fuzzy boundary in there. But it's a great question.
Thank you so much for this presentation. And I'm curious, do you believe, or is it true that if you plant a lot of trees, you can actually attract moisture?
Yeah, that's a good question. I mean, I think I guess it depends a little bit on your definition of a bunch of trees, right? Like a few trees in in your backyard or something probably is not going to have much influence, but like reforestation of an area or deforestation of an area can have a big influence on how much precipitation falls in that area. So I mean the largest scale example of that is like in the Amazon, right? It's a rainforest, but there's places that have been deforested, and that very much can change the precipitation patterns in that area. So, but it's also a bit of a matter of scale. Like at the, if we're talking about like an acre or two of trees, maybe doesn't make a big difference, but on the scale of like a whole forest, it adding or subtracting trees can make a difference for sure. Or in the case of wildfire, right? Like some of my colleagues at CSU are measuring the changes in snowpack and precipitation from forest areas that have been burned, right? And it can when you have these 100,000 acre fires, it can affect the weather and climate in those areas for sure.
Okay, we are going to take a break right now. Dr. Russ is still here, so if you have questions, I'm sure he'd be willing to entertain those. But we're going to take a break. We'll join back here at 10:15.